back to Josh Does Math. In this video, we're going to be using the definition of a derivative to calculate the derivative at a specific point on f of x. So this is the definition of a derivative, which you should know. F of x is equal to the limit as h approaches 0 on f of x plus h minus f of x all over h. And we're going to be evaluating this equation, and then we're going to be plugging in x sub naught for x, which shouldn't change too much. But this is our f of x that we're given. We're given x squared minus 4. So if you were to graph that, it's just a parabola that you shift down a little bit. So it's something like that there. So we're looking for the derivative of this parabola. So that's giving us the instantaneous slope at any x value on it. So there's some slope lines, very poorly drawn. So I'm going to use this equation right here, writing limit as h approaches 0 on, I'm going to skip the beginning part. I'll write the second part. F of x is just x squared minus 4. Make sure that that's in parentheses. For the beginning part, I'm writing out f of x, but in for every x, I'm plugging in x plus h. So this is going to become x plus h squared minus 4. So see, I just, instead of x squared, I did x plus h squared. And that is all over h. And I'm taking the limit as h goes to 0. And as you can see, if I were to just plug in 0 for h, I'm going to end up getting 0 over 0, which is an indeterminate form. It doesn't tell you anything about what this limit is equal to. So our goal is to not get an indeterminate form. And if you want to be able to accomplish that, you need to do something within the limit, either manipulate it algebraically, do something like that so that you don't get this indeterminate form. So I'm going to manipulate this algebraically, so that's probably the easiest thing to do with this. So I'll write it out. I'm going to use FOIL right here and use the distributive property for this second thing in parentheses. So limit as h approaches 0, I'm doing FOIL, so that becomes x squared plus 2xh plus h squared. I still have the negative 4 in there, and then I'm subtracting x squared and then adding 4. That's all over h. As you can see, some stuff is going to cancel. I'll just cross it out as I see it. X squared and negative x squared. Bye-bye. 4x, 4 and negative 4. Bye-bye. And I'm left with two things involving h in the numerator and h in the denominator. So I can just divide each of those terms on the top by that h on the bottom. So I end up with 2x plus h, and that's it. Limit as h approaches 0 of this. And now I can do direct substitution. I can just plug in 0 for h, and that's just 2x. So this tells me that f prime of x is equal to 2x. In other words, if you give me an x value, I just put that x value in for this right here, and then I can give you the slope at that x value at that point. And this is accomplished just by multiplying by 2. That's all it does. But I want the x value, I want the slope, the instantaneous slope, the derivative, at x naught, not at x. Which, that's pretty easy to write. You just do f prime at x naught. You just plug in x naught for every x. And that's the answer.